Okay, this is going to be the virtual lecture for cit162. We're going to talk about lesson 4. If you notice, these two lessons in Networks 3 right now are one topic lessons, so we're just kind of getting them out of the way. We're banging them out. And then once we're done this week with this lesson, then we're going to spend some time on a rather detailed project, I think, and do a little bit of practice catch-up time. So that's the game plan, and we'll go from there. I'm going to share out the screen right now for here it is with our Dunkin' Donuts April Fools. All right, so we're going to be doing, again, lesson 4. I'll be getting the practice and the assessment out there. As you can see, I got the shells already built out, and they're just not available. They're hidden from you. But we'll get from there. The lecture we're going to be covering is not 100% done itself, actually. Everything we need for today is done. I'll be adding to this a little bit later on as we get through it. So any questions before we get started? All right.
I have a question, like, just to clear myself. It's Mo.
Hi, Mo. What's up?
So about your email yesterday, or probably you explained, I don't know, I just joined, that's why I just want to clarify myself. So you said it's by midnight, the lesson 4 assessment, which means, does it due by midnight, or are you going to post by midnight?
I'll have it posted by midnight. So in other words, by the end of the day today, I'll have that posted.
Okay.
Is what's going on. Sorry about the...
So for a second, I lost my heartbeat. I was like, is it going to due by midnight?
No, it's not due by midnight. It won't be due until, was it May 14th, I believe. So.
Okay, Professor. Thank you.
Yep, no worries. All right, so there we go. Let's get started. I'm going to move this out of the way and hit present. I like to have a little funny reference in the start of all this. This just came from sprung from the top of my head as I talked about this. Again, the world of Cisco. Cisco's very old. iOS is very old. It goes back to the 80s, right? And because of that, it's security is a bolted-on feature. It's not at the core, right? We were in the 80s. We were just happy when stuff worked. So anyway, that's why I called it tiny bolts on a rickety fence, because we're going to talk about some different security aspects of iOS. Right off the bat, we're going to talk about access lists, which will eat up the majority of this class, and that's what this lecture will essentially be about, our access lists. But we're going to talk about other things like access class and privilege levels, things that can add security to Cisco, but are not really, it's still, again, kind of bolted on features, right? So let's talk about access lists right now. And then we'll take it from there. So access lists, what are they and how to configure them? All right. So the first thing that you need to understand about access lists they are top down. Okay. What's going to happen is an access list is going to, and we're going to see this in a bit. So when I show you an access list, like for example, this one right here, extended IP access list, what's going to happen is it's almost like a checklist, right? Every packet/segment, depending if you're going to do layer 4 matching or layer 3 matching, is going to have get lined up with this list, right? And just think of like a bouncer at a club, right? They're just going to go down the list and say, hey, what's your name? Okay, and they're going to bump, 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 bump. They're going to go down the list. If you're not on the list, you're out. Okay, access lists work essentially the very same way. It's very important to keep in mind that they're sequential, because what you can do is you can sit there and say, okay, this workstation's allowed, this workstation's allowed, this workstation's allowed, but all the other workstations are not allowed, right? You don't get, once you match your criteria, you're processed and then they move on, right? You either go or you're denied, okay? So case in point, if you have an access list that sits there and says, they are allowed, and then right after it says they're not allowed, well, they're allowed came first, so they will be allowed, okay? So it's an important concept, okay? So it's sequential, it's gonna go down the list. The moment it hits a criteria, it's gonna be, that packet will then be processed and moved along. The list processing stops there. So if there's anything below that list that affects it, it won't get to that part, okay? It hit a criteria of one of the access control entries, or elements, and it's going to get acted on, okay? If no criteria is matched, by default, it will be tossed, okay? We're gonna talk about this in a little bit, but there's, we like to call it an IP deny any at the end. There's a deny any at the end, okay, of every access list. So by default, it's not shown, but at the end of every single access list, there's a deny any. In other words, we're gonna deny everything else. So if you don't meet any criteria, the default is to drop it. Now, there are special access lists. You can reverse that process by saying deny this, deny that, deny this, deny this, and then at the end of all your denies, put a permit IP any. In other words, we're going to permit any kind of IP traffic, and we saw that in security too with our firewalls. We use those commands at the as catch-alls sometimes. So you can reverse the process. Okay. Ironically, after that IP any is still a deny any, but because everything is hit by the IP any above it, the permit IP any above it, that's what gets enacted on the IP any. The deny any gets never gets hit. Okay, we'll see that in a little bit. But so the important thing is to keep in mind that they're sequential. In other words, they're going to go down this list, and once you hit a criteria, it stops processing. That packet then gets processed either forward or denied. And then that's it. It doesn't keep going down the list. Okay. So there are different types of access lists. Again, this has been around for a very long while. So you got like IPv4, IPv6. Yeah, that's good. IPX, right? Going back to Novell days. DECnet, that's going back into the 80s when Digital had their own networking protocol. AppleTalk has access lists, and there's others too. What we're going to be concerned about is IPv4. That's what we're going to learn right here is IPv4, but there is provisions to do IPv6 as well. So let's just look at IPv4 right now. I'm going to get my pointer. There we go. So IPv4, all right. You don't have to memorize this. I'm not going to make you memorize this. So in the early days, there's only 1 through 99. The first 100 or 100 numbers 1 through 99 were were standard. They were the standard version of access lists. So what a standard access list does is just checks for the source address. So it's only going to concern itself with the source address, right? So at the end of the day, remember we have. I'm going to do the whiteboard. Go back and do our good old-fashioned packet here, right? I'm just going to draw that packet again, like we always like to draw, right? So we're going to have our data, right? We've got our layer 2 footer. We're going to have our layer 4 header. We're going to have our layer 3 header. And we're going to have our layer 2 header, okay? What an access list can concern itself with is it's got all this data here, right? We have our source IP and our destination IP, okay? And then over here, we have our source port and destination port, okay? Now, the standard access list is only going to concern itself with the source IP address, okay? It doesn't care about protocol. It doesn't care about port numbers. All it cares about is the source IP address, okay? And again, it's going to have a number of 1 through 99. Now, what happened was, and especially really large networks, and anyway, there was a demand for more access lists, believe it or not. 100 access lists did not get the job done for some people. So they actually opened it up, and now 1,300 through 1999 is also standard access lists, all right? Extended access lists is how we're going to spend more of our time. And I made a big movement down below, so that thing's going to pop up. Right, that goes away. We have extended access lists. Extended access lists will use 100 through 199, or you can use 2,000 through 2699. Or you can also, by the way, we're going to talk about this. Both of these we can have named as well. We can, instead of using numbers, and this is a relatively new concept. It started in the late 90s, but really didn't get pushed out until the early 2000s. When I first started learning access lists, I didn't have the ability to name them, or I wasn't taught to name them. Anyway, we'll talk about that. We can name them as well. We'll actually do that quite a bit. The extended access list, not only does it check the source, but it can also check the destination address. It can permit or deny specific protocols and applications. So it can look at the source and destination port, TCP and UDP ports. So you can tell it only look at UDP ports. You can tell it look at TCP ports. You can deny based on protocol type. Obviously, that's why I mentioned, you heard me say IP permit any. That was an extended list, right? Because we're saying permit all IP traffic. It doesn't matter if it's TCP or UDP, which are sub protocols of IP, right? We're gonna either allow or deny all IP, or we can do internet control messaging protocol. Is it internet? Yeah, inter network control messaging protocol. ICMP, right? That's going to ping requests, echo requests, echo replies. That's part of the ICMP scope. We can just do UDP, we could just do TCP, and we can set protocol numbers. I'm going to give you some examples in a bit, okay? So the takeaway here is access lists are sequential. When you hit a criteria, it processes the packet and moves on. All right, it stops the list. Okay, it doesn't process the entire list for every single packet. The moment a criteria is hit, that packet is processed and moved or denied based off the instructions. Okay, but the access list is top down. It's going to work from the very top of the line to the bottom, top line to the bottom line. And there's two, as far as we're going to be concerned about, there's going to be two types of access lists. There's standard, which is going to be 1 through 99 or 1300 1999, or extend. And standard only checks for the source IP address, as compared to extended, which can check for the source, destination, and protocols. Any questions so far? Okay, so we're going to move on. Access lists, this is how you actually configure them, right? Let's start off with standard because it's nice and easy. So we have, I'm now branching out the commands and making them look different. I hope that works for people. Right here, we got router 1, RTR1. It's in config mode, global config mode, and I type access list 1, right? So in this case, I labeled it access list 1. It's the first access list number, right? That's a standard, right? The very fact I use the number 1 makes it a standard. Permit, remember, it's only source IP, so this is all it cares about, 162.16.0.0. Now, this is not a subnet mask, 0.0.255.255, right? Okay, so this is standard access list. It's using number 1. That'll look for the source IP of 172.16.0.0/16 and let it through. That's what it'll do. After that, everyone else will get denied. It's that simple. Whatever interface has this access list, this is the only entry in the access list. What this access list will do is we'll look at the source IP address. If it starts with 172.16, it's going to let it through. Okay, everything else it's going to deny because of the implicit IP deny any. Not IP deny because this is a standard. Deny any. It would have a single deny any at the end. Okay. And it would drop all other traffic. All right. Wait, what? 0.0.255.255. Yes, because access lists use wildcards. We talked about this a little bit earlier, but for folks that haven't been exposed so far, yeah. All right. Welcome to Cisco. Simply put, same as a subnet mask, but instead of zeros, but ones are zeros and zeros are ones. Okay, we just reverse the process. Okay. Now, I used to make fun of people, and I said, I don't know if some like Cisco engineer just got, just preferred to that thought from the very beginning, subnet mask should be this way, and they just set it up this way. But the argument for it, as I did a little bit of digging around this last week, was that because these are wild cards, right? We're not saying these are networks, right? This is just a wild card mask, okay? So what we're saying is they wanted you to think of it differently. We're not creating subnets, right? This is not a 172.16 subnet. What we're just telling the access list is you filter based off of these, off of this mask, okay? That's why they want it different, but it's still very confusing and people hate it, but that's life. So a /27, right, is going to be 255.2, when it comes to subnet mask would look like this, 255.255.255.224. In wildcard, it's going to look like 000.31, simply because all these ones for 255, 255, 255 will become zeros, right? And in this case, we have 224 is what? Three ones, right? It's 128, 64, and 32 combined is 224, right? So we have 3 ones, and all the rest are zeros. Well, it's going to be the reverse for wildcard. So it's going to be 3 zeros and then 5 ones. And if we add up the 5 ones, 1 plus 2 plus 4 plus 8 plus 16, it's going to be come out to 31. Okay. The quick way you can do this is, let me go to the whiteboard again, and I'll clear it. Erase, I guess. I can just do clear. All right, good. Clear. I'll clear all drawings. Clear my drawings. Clear viewers' drawings. Sure, I'll clear them all. All right, so one way to think about this, the quick, easy way to do this is let's just come up with some subnet mask, 255.255.255. We just did 224, so let's do 240. All right, say we have a subnet mask of this. This is what we want to do, right? Well, the wildcard is real simple to do. Just put 255.255.255 above it, and you can subtract it. Okay. So if I put all these above it, obviously this becomes a 0.0.0, and this over here, what do we have? 15. Okay. And in a way, it makes perfect sense. Again, because if you look at this mask right here, it's got a 1, 1, 1, 1. It's got 4 ones, and all the rest are zeros, right? In this mask right here, it's going to be reversed. It's going to be 0, 0, 0, 1, 1, 1, 1. So if we added 1 plus 2 is 3. Plus 4 is 7, plus 8 is 15. Okay, it's just another way to make life a little bit more fun. All right. Any questions about wildcard? Adam has his hand raised. Go ahead, Adam.
So just to go over the example on the slide again, the 172.16.0.0, for that permit, that is allowing anything on that network to go through that would have that host prefix. So I know on the wildcard you're saying, okay, well the wildcard is not necessarily a subnet mask saying that this is really a network, but really anything with that network prefix or any device that's on that network would be let through that entry on the access list, correct?
Well, there's no guarantee. I think I understand your question. So there's no guarantee that this is a network, right? That would be Cisco's argument, right? The network could actually be 255.240 because it's 32. Yeah, 240. .0.0, but we only want the dot. We're only going to let the .16 folks in because they have access to the server, right? So their argument is not necessarily a network, and that's why we're going to use wildcards, right? But it does function for all intents and purposes the same way, right? By the way, if I go down here and I type show access list into the router, this is what I'm going to get. Okay. This thing needs to go away, but you know, it does that. All right. If I type show access list, this is what I'm going to get down here as a list, and it'll tell me wildcard bits 255, 255. So again, it's going to match 172 and 16. But again, if the actual network itself is 172.16.0.0//18, I think off the top of my head, then that would mean 16 through 32 is covered, right? Because it's 24, so the increment would be 16. So if I did, it should be 8 plus 12, sorry, /12. 172.16.0.0/12, then my network actually is 16 to 32. It's the whole thing's a network. But when this access list is applied, it will only let things that have 16 in it through this access list. Does that answer your question, Adam?
Yes, thank you.
All right. So it's not synonymous with network. It doesn't have to be synonymous with network, and that's that again is Cisco's argument for using wildcards, is so people don't think it's synonymous with networks. But often it is synonymous with networks. It does often go hand in hand. So much so that I spent many of my days cursing wildcards. But that's their argument for keeping it. Any other questions? All right. Thank you. We'll move to the next example, which is setting up an extended access list. Okay, whoops, I kept that. That should be 101. Again, even though I'm being recorded, I'm going to change that. You'll never know, and I'll deny it ever happened. 101, there you go. This is an extended access list 101. I'll get my pointer. We know that because that's my number right there. We know it's extended because it's 101. It's 100 and above. 100 to 199 is going to be, make sure I got that right. I said it. I better make sure. Yeah, 100 to 199 is an extended access list. So we know this is extended by the number I used. Okay. We're going to talk about names in a little bit right here. This is a named one. We'll talk about that in a second. It's a little bit different to set up. So we're setting this up as 101. All right, and it's got a permit. It's permitting TCP. Notice that it's using a protocol saying, "Hey, only allow TCP traffic from any source." Is always sourced and then destination. Okay, so any source. I don't care about the source. To the host 192.168.1.1. Host is a special command. Now we don't have to use host. We could use 0.0.0.0. which would tell it has to match this IP address exactly, and we'll use that a little bit later. But I just want to show you as many keywords as possible right here. So this says, dividing it up into sections. Access list 101, okay, it's an extended access list. We're permitting, okay, great, it's a permit. Okay, now TCP, all right, it's got to be the TCP protocol. Okay, any source, so this is the source, any source. Destination, it's a host. The host IP is 192.168.1.1. Okay, and find it equals www, and there'll be one more thing, but equals www. I could have just put equal 80. It'd be port 80, but they have these buzz phrases marked in here already. Again, you can hit question mark, and EQ is short for equal. Okay, you can do a range of port addresses, which is RNG. I don't think or maybe it's just RAN. It might be range. I have to remember off the top of my head. Anyway, you can do a range. You can do the opposite where it does not equal. So in other words, you can sit there and say, allow all other ports but this port through. You can do lots of things with this. And again, if you question mark, it'll give you the full list. And then www is just shorthand. It's not even good shorthand because I can just write 80. But if I can't remember what port what World Wide Web is, they put a shortcut in there for www. Again, it's the same thing as putting port 80. And then finally, I have log. Okay, log means what will happen is it will log the fact that someone or something, an IP address, which IP address too, by the way, and the time activated this access list. So this access list was activated. Someone hit it. They were allowed through. It'll give me the IP address and it'll give me the time. Okay, there you go. This is it will match packets from any source going to the single host 192.168.1.1. It will destination port of 80. It will also log the hit. Okay, so it'll create a log in the syslog of the IP address and what time someone hit it. Again, we'll talk about logging in a later lesson. Okay, logging is kind of can be a little bit of a. It's got to be you got to manage it because there's not enough storage on a switch or a router to record every single hit. So you got to offload that. We talked about it a little bit in other classes, but we'll talk about it here in a different lesson. All right, so that's your first exposure to an extended access list. Again, the big things to remember here is it's source first, destination second, and then you put what protocol. You can also base it off the protocol of the source, but often that doesn't make sense because the port numbers of the source are often going to be dynamic ports. So it doesn't make sense, okay? You can still do it. These things are very configurable, very agile. You can do anything, which adds to complexity. If you said, well, what if instead I want to put this near my servers and permit my servers only to respond back on port 80? Yes, you can do that. You can put in this. You can specify a specific port on the source. But so anyway, the takeaway here is you have source first, destination second. Destination also has, in this case, has a port number, and you can log the entries. I'm going to move on to named ones, but I'll take a little bit of pause here to see if anyone has a question. Maybe take a sip of my tea here. Okay, so let's talk about named access lists. Okay, so in this case, the way a named list works, it's going to work a lot with these numbers. This was from my understanding, back in the 90s, people were crying out saying, why don't we have line numbers? Because what we have to do back in the good old days, you would type these in one at a time. You'd say access list 101. All right, I'm going to permit this. Okay, I'm going to permit that. I'm going to permit this. And then I'm going to and then I'm going to exit out, and I'll apply the access list. We'll talk about how we're going to apply the access list to an interface, and then it's up and running. And then, oops, I got to add something to it, right? We're adding a new service to a server, or I forgot something. And then what we would end up doing, and believe me, I've done this, is I would copy the entire access list over to a notepad, put in the command I wanted to put in the certain where in that processing list I wanted to be processed, hit no access list 101 with the numbered access list, and then just copy and paste my access list back in, which is really silly. I mean, it was, a lot of people were like, this is ridiculous, right? Especially if I just want to do something temporarily. Why can't we use line numbers, right? And why can't we name our access lists, right? Instead of it's relying on numbers, right? So that's what they did. They pushed that out as a separate feature. So you can do this to both extended and standard. So you're going to do how this works is in the global config mode, you're going to set up an access list. It's like the DHCP pools, right? We're going to go into a separate mode once we name this thing, okay? So we're going to name it. In this case, we have an IP access list. It's going to be extended. You have to tell if it's going to be extended or standard, and then you give it a name. In this case, the name is example. Okay, so this command establishes an IP extended list called example. And then we can start typing out. Notice I have line numbers to start them off. 5, deny IP. So remember source destination. So I'm going to deny the 192.168.33.192. In this case, I'm going to be it's going to be a range of IPs with a 0.0.0.0.64. So that means was at 254. So I'm doing the math in my head. 255. So it'd be 192. So the first 2 bits, right? The first 2 bits are going to be paid attention to here, right? So the increment's going to be 64. Okay, so this would cover the whole end of this subnet. So it'd be 192 to 255 would be would get caught in this net, right? So it'd be a deny IP 192.168.33.192 all the way to 255. Yes, in a more friendly way, in a more commercial home router, you would just put a range of IPs. In this case, the range would be 192 to 255. But we're Cisco folks, so we're going to do wildcard, and we're going to do 0.0.0.63, and that says everything from 192 to 255 to any destination. So we're going to deny these source IPs to any, and that's the entire IP suite, okay? Not anything particular like TCP with a certain protocol, just all IP traffic, we're denying it, okay? And then we're gonna have another line here, a number I specified myself. By the way, if I started typing things out like deny IP, I didn't put a line number, it would number the lines automatically for me with 10, 20, 30, 40, 50, 60, okay? They're gonna leave gaps in between, that way you can stick things in between. That's the whole point of line numbers, so you can stick things in between. All right, so we're gonna have the next line, I got 15, that's my line number. I'm gonna permit the IP 192.168.33, 128. This one here is nice and simple, it's a 127, so that means it's /25, which means it's gonna be the whole back end of the 33, right? So what interesting thing about this is the first thing, it's gonna deny the back half, 192 all the way to 255 will get denied, but 192 to 168.33, so 128 to 191 will be permitted through, right? Because again, what's going to happen is, let's say 193 comes through, right? 192, 168.33.193 comes through. It's going to hit this first, get denied. It won't get down to this permit. So this permit will not affect it. Does that make sense? Because that's an important concept, okay?
Yeah, do you think you could just explain that a little bit differently? I'm having a hard time understanding that.
Sure. So because this is because the list is processed sequentially, right? And there's of course an implicit deny any at the end. Let me go to the next slide because this is the one where I show the access list. So if I go back into enable mode and I type show access list enabled, okay. And I think Adam, this raised hand was from the previous raised hand, and I never lowered it. Is that right?
No, this is a new question.
Okay, good. All right, I'll get to you in a sec then. So if I go to enable mode and do show access list example, right? Here's the actual extended IP address list example, right? I have 2 lines. I have even though there only lists 2 lines, there's actually 3 lines because remember you had that deny IP any at the end of this, right? So we got our first line, which is 5. The first line is 5 deny IP 192.168.33.192. Wildcard mask of 0, so it has to have a 192. 0, it has to have a 168. 33, 0, so it has to have a 33, and then 63. So that means it's only going to match the last, I'm sorry, 6 bits. It's only going to match the last 6 bits, okay? So anything from 192 all the way to 255, and actually it might be 193 now that I think about it. Yeah, only 193 to 255 will get a hit, okay? The second line says permit, same IP address, but this case it's going to be starting at 128, and it has a wildcard mask saying the first 7 bits are what you're going to match. So it's only going to match 129, right, all the way to 255. Because if you have 128 come through, that just means the first bit is turned on. That's not part of the match. It's not even looking for it, right? Remember, the way this works is, I'm going to bring up my whiteboard again, right? It's just like a mask, right? So it's going to sit there and say, in this case, we had a .63, right? So we have a .63. So what that looks like is we have all zeros, so 0, 0, 0, 0, 0, 0, 0. All right, we're going to repeat that for the second octet. We're going to repeat that for the third octet. And for the last octet, we're going to have 0, 0, 1, 1. Wait, did I do that right? 1, 1, 1, 4, 6, 8. Let's see, we got 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, plus 16 is 31, plus 32 is 63. So that would work, right? So these are all, it's only going to match things based off these last bits, right? This is where knowing those, going back to doing our subnet calculations, knowing those bits and bobs and knowing the actual binary, how it was working in the background, this is why your brain, if you truly had a great feeling for that, then this is where this is going. Yeah, no big deal. But if you're like, oh, I just did the shortcut method or I looked up things on charts, then this is going to be like, what the hell is going on here? Again, you can always reverse it and find out the right answer by adding it with 255. Let me clear the drawing here. So if we got that .63 and 0.0.0, right? We can always figure out what the original subnet mask is by adding 255 or subtracting 255 or getting to 255. So we got to get to 255, figure out what the actual subnet mask is, right? In this case, it's easy. It's 255, or the first 3 bits are 255, 255, 255. For this last one, if we subtract 255, 63 from 255, we're going to get 192. Okay, so that's what the subnet mask would look like in the regular world of 192. Both of them mean the same thing, which essentially is a slash. This is a slash. It's the first 2 bits of /26, and this is a /26, right? It just means the first 26 bits is not going to be matched, or is going to be matched, and the last ones will not be. Yes, that's. So, or am I reversing that? Anyway, that's what a wild card is. So in this case, because we have a .63, we're telling the access list that 193 all the way to 255 needs to be matched. Everything else is not going to be matched. Okay, so if you have a 191, for example, I don't really care about that. The 191 will not get matched. Okay. So, and because it's sequential, so we have this one first, If I come through with a 193, for example, I'm gonna match this entry in the access list. So then it'll get acted on, which means it'll deny my IP traffic. If it's IP traffic, it will deny it. Even though I go down to this next one and this access list would have applied to me, because this one was first, it gets applied first. If this gets reversed, if we reverse these two and I give this a 25, for example, so now all of a sudden it's below this one, I put the deny after the permit would have been acted on first, and my traffic would have been allowed through before I could get to the deny, right? It's just like a bouncer. It's going to go through, so yep, you're allowed in. Or if right before, say they're going through the list and it says, I'm going to pick on Adam. Adam, you're not allowed. It says Adam is allowed in the club, and the next line says Adam's not allowed in the club. It's a stupid bouncer, hits the first line, says, Adam, you're in, and it lets Adam in, right? So the only way to make sure Adam doesn't get in the club is to put it above that line. All right. Does that make sense a little bit, Nathan? Was that where you were getting tripped up?
Yeah, it was that in the math, but now that I see, because I was trying to understand what the zeros were representing, and it kind of reminds me of a MAC address with like the foreshortening with the 2 colons, kind of just make things a little bit shorter.
Oh, well, again, it comes down to 0 because, and maybe the Cisco engineer that came up with this maybe didn't like writing 255. I don't know. But
I don't mind it, honestly. I just drew a line to it, so I'm like, oh, okay, that makes sense.
Again, all it happens is it's kind of like a subnet. It is exactly like a subnet mask. It just applies. It just ones or zeros or ones. Okay.
Right. Yeah, I was just thinking like FE80 and then colon where you would fill in the rest of that. That's just the main thing that I compared it to. But no, that makes sense.
All right, so what does this buy us? Having names and line numbers, particularly line numbers, okay? So if, for example, I forgot something, like I want to permit 33192, I want to, in this case, I want to permit 193 to, let me do some quick math, 32 to 223, right? Or 224. If I want to permit 193 to 224 for whatever reason, I'm like, oh shoot, I need to get those people in, right? They need to be able to access this, right, or get out of this network. Then what I can do is I can then go back into that IP address list, the access list, type IP, go back to config mode, IP access list, extended example. That puts me in this special mode. Notice it says config extended and access list here, a network access list is what it's short for, I believe. And then I could put number 2. And what that number 2 does is it puts it right before number 5, right? So I put number 2, and now I'm gonna permit 192.168.33.192.0.0.0.31. So that's gonna let through the first, it's gonna allow 193 to 224 through. And now if I show that, now I'm doing a do show access list. So I'm doing it as if I'm in enable mode. And then here's my new access list, right? I've got my number 2 is first. So it's going to permit this through. Then it's going to deny this, right? So if I come in as 193 again, I'll hit number 2 first and it'll permit me in, okay? But if I come in at 225 doesn't get hit by this. So then it gets hit by this and it would deny it, right? Again, this is kind of oversimplified because we're using permit IP. But if we're sitting there and we're setting up an access list that's permitting and denying people to get into a server, what I can do is allow certain IPs based off of this access to the telnet, but not to web and telnet, right? I can almost think of it as like a granular filter, right? When you got a bunch of different sand and you're trying to flush out the different grain sizes. That's kind of what you can do with this, right? If you're smart enough, right? And again, it can get really complicated. It can turn into a very complicated web very quickly. Here's another example of an access list. So I did IP access list extended. I called it EX2, short for example 2. Let me put that there. All right, so I can see it. So what we're going to do is we're going to permit TCP 172.16.100.0. Nice simple wildcard. So it's got to match the 172.16.100, and it's going to let everyone in that whole, no matter what your last octet says, it's going to let everyone else in. Okay. the source is going to be 192.168.1.1. Now, notice how I have a 0.0.0.0. Again, I could have just put host name or host. I'm sorry, not host name, host, or HO for short if you want. In front of this, and that would have said the same thing. But what this says is 0.0.0.0. What that's saying is we're matching this, we're matching this, we're matching this, and matching this. It has to be this IP address exactly. Again, this is where it adds confusion though, because naturally we've already done this, and you're probably saying, oh, quad zero, right? We've done quad zeros before. Yes, but when you did it that way, it reversed it. It said everything, right? And this one, because it's wildcard and it's reversed, it means this specific IP of 192.168.1.1. Okay. Now, because we did TCP as the protocol, we can then say equals www, which is port 80, right? So it's going to allow web traffic through for these folks. It's going to deny or permit. I'm sorry, I was looking ahead. It's going to permit 172.16.100, the same network, the same. Well, I don't want to say network, but the same hosts that start off with 172.16.100. That everything that starts with those 3 octets is going to be allowed through to 110, which is POP3. Yes, it's POP3. So it's going to allow POP3 in to this server, which is a different server, but 192.168.1.2. Again, it has to be an exact match to that whole IP address. Okay. And then finally, it's going to deny that that collection of IP addresses, starting with 172.16.100. It's going to deny it to the entire network. Notice how deny IP, so deny the rest of the IP stack, the protocol stack, to 172.16.100.0.0.0.0.255. So it's going to allow that through anything starting 172.16.100. And it's going to deny it to 192.168.1.0 with 0.0.0.255. So anything that starts with 192.168.0.1. Okay. If I do a show, it's going to just show what I just typed out there, right? And notice how I didn't put line numbers. It put them in there for me, 10.20.30. Okay. Oops. Let's add the ability to ping for the workstation 172.16.100.1. Apparently that's the admin or someone that just needs to be able to ping people. So what I'm going to do is I'm going to put line 25 in. I won't put it after the denies. And by the way, you might sit there and say, well, isn't that deny superfluous because there's a deny IP any at the end of that? Yes, it is. But maybe I want to put some permits after that too. I don't know. But so as it stands right now, this is superfluous. I agree that deny IP at the end is superfluous. It's not needed because there's a deny IP any implicit at the end of every access list. Anyway, so then if I do IP access list extended E2, I go back into it. I give it a line number 25. I have to put it before the deny, right? If I gave this a line number of 35 or I didn't give a line number at all, it would put it as 40. I would get denied anyway because it would hit this part of the access list and then act upon it, right? So I put it before the deny. I put 25. I permit ICMP. It's part of the ICMP protocol. The host 172. So it's the same thing as writing 0.0.0.0, 172.16.100.1. To the host, we're only going to allow it to ping this IP address for whatever reason. It needs to check the web servers up, right? 192.168.1.1 equals echo, which is the echo request, all right? It's going to allow the echo request through now, all right? So that's me adding in. Oops, I forgot to add that in. Now I can use a line number, add that in. Any questions about that? This is configuring access lists. Now we're going to talk about deploying them, which can be just as tricky in a way, right? Because it's one thing to build an access list, but when you actually start applying it, like I think about where I apply this, right? If I apply this at an interface next to the server, it's gonna cause, it won't be the same, it won't, remember I have to keep in mind source and destination, right? And when the server sends the traffic back, it's gonna be the source and the destination are going to be flip-flopped, right? So when it comes back from the server, this 192.168.1.1 with the IC echo request is going to be the source, not the destination. So where I apply this access list is going to matter a lot. But we'll talk about that right next. Any questions before we move on to that? All right. So access list config, how to apply. All right. what we're going to do is we're going to go into the interface we want to apply it. So in this case, we have interface gigabit 01. We're going to just, once we're in there, we type IP access group. We're going to use the command access group. We're going to give it the name of the access list, and then we're going to apply it to the outgoing interface. Wait, out? That's right. Every interface has an outbound and an inbound, right? And it gets confusing as hell, believe me. And I still have a hard time picturing in my head because it gets flip-flopped, right? Let me bring up the whiteboard. So we'll clear this. All right, every router, here's our router, is going to have an interface, at least multiple interfaces. And then that interface is going to have an inbound, which is this. It's coming in from the subnet, and the outbound, which is, wait, did I reverse it already? I probably reversed that already. Yes, inbound, right? So this is traffic coming in from other subnets, and outbound, this is traffic going out to other subnets, okay? Again, it's important to get this, and believe me, I can't tell you how many times in my life I sat there and built this perfect access list and simply applied it to the wrong inbound or wrong outbound, and it didn't work worth a damn because it flip-flopped everything because the destination became the source became the destination. So this is why we test everything with pings and everything else before we walk away, right? So again, here's my switch. So we got a switch here. This is a switch here, right? And we're going to have a workstation out here, and we're just going to ping some other workstation out here, okay? So every interface has an inbound, right, and an outbound, okay? And how we apply this is going to affect what the source and destination is, right? So that access list I just did was an extended access list that had a lot of source. The data was really about the source, right? It was like, we're allowing this network through with this source going to that destination. So that is something I would apply to the outbound interface, right? We're leaving that interface. So this is where I want to apply it, because those sources, that would be that one, it was a 172. 172.16, I believe, .100 network /24, right? I'm not going to say that's the network, but it's applying to those workstations. So that would need to be the source, and the destination would be this 192.168.1.1, if I'm not mistaken. 168.1. whatever network that's over here, right? And because that's the destination, we have to apply that on the outbound. If we applied it on the inbound, that access list would just all of a sudden block all traffic. Why? Because there's that implicit deny any at the end of it. Okay, and it would just simply block all traffic, because it would sit there and say, nope, 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 nope. We go down all the criteria, all those permits we made, and we go, nope, that's not the source, 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 deny it, and it would deny everything. Okay, so again, this is why we need to test things when we think we have it. Okay. So you either apply it to the outbound or inbound. Again, this is one of those things until you actually hit the enter key and you're struggling and you're getting a ping working or something, and you hit the enter key and it works, that's when you have the aha moment, because it's really hard to describe. It's really hard to keep in your head. Believe me, I've been doing that for many years, trying to keep it in my head. You saw me kind of screw up a little bit right there. So we can apply it either to an inbound or outbound. The source and destination get flipped if you don't apply it to the right one. Oh yes, and please, please, please use remarks so you can tell us what you're planning on doing, right? IP list extended, in this case, I've made a line 24 remark, allow admin to ping. Let me not go over there because that way that thing disappears. Allow admin to ping the 192.168.1 network. Actually, it's not what it did. It actually, well, that's what that command did, but that's not the one I put in there. Anyway, so using the remark command, as you can see right here, and see if I can not activate. Yeah, activate. But using this right here, this remark, what I can do is put in just information, and I can put little lines in right before a line saying this is what this does. Okay, and that way, if you're if someone else is troubleshooting your access list, they can actually try to figure out what, it's just like lines of code, just like going back to your code class, right? You're going to put remarks in to let people know what you're trying to accomplish. That way, if they're troubleshooting it or editing it, they can understand your madness, right? So access list deployment. How do you deploy this? Well, whatever works, works, right? At the end of the day, if it gets the job done the way you want it to get it done, great, right? But you better test everything, right? Test all the possibilities, okay? So best practices, things to keep in mind. You want to use standard ACLs close to the destination, right? Use them more for destinations. So because remember, you're only allowed to use the source. So what you can sit there and put it on going back to my drawing here, right? If I was using a standard access list, again, the beauty of a standard access list is nice and simple. But if I was using it here and this was an actual server like we had in the demonstration, what I could do is apply that over here on the inbound and say, hey, if you're coming from the 172.16.0, 1.100.0 network, right? So it'd be 0000.255. If you're coming from that network, let it in, permit, right? Or deny, right? I would either permit or deny based off what's coming into my network, but I would keep it close to the server, right? A standard, because if I go over here, I can't really, it's the lack of control. It's almost like, I'm trying to think of the best way to put this. It's like figuring out, it's like controlling a nozzle, right? If you put your thumb, if you're sitting there saying, hey, I don't want to get this one plant wet, well, but I want to water all the rest of the plants. Well, the best way to control that is to put it near the plant, put some kind of, plastic cone around the plant and then spray everything, right? As compared to using your thumb and trying to make a perfect like hole in the water, right? That's coming out and spraying all the plants, but not spraying that one plant, right? So you want to be with a standard, because it's such a big tool. It's such a clumsy tool. You want to use it closer to the destination, okay? As compared to, and again, these are rules of thumb. You can violate those rules. If it works, it works. But extended access lists work better closer to the source, right? Because that's what we're doing. We're trimming down the source, right? It's such a precise tool. We can sit there, go to the source and say, all right, that IP is allowed to go to web. This IP is allowed to do telnet. This IP is allowed to, right? We can do that better with an extended access list, okay? You need yourself what I'm trying to do. What the heck? You need yourself what I am trying to do. Wow, I don't know what I was going for there. If you're trying to regulate the behavior of a whole network, you might want to be close to the source and use extended at the egress. If you simply want only certain IPs to be able to access a server, you should be standard closest interface to the ingress. So I was, instead of using this, and this is how we'll end, I was going to use this, and we might start off next class with that. So I didn't really need to kill myself and get this up and running, but so be it. Oh, I forgot. I got to manage. I got to do this sharing, new share. I'm going to share my whole screen, actually. There you go. Share. All right. Everyone should see my screen now. So this was what I set up real quick, was a quick little network. Where I had a couple devices and a web server, right? So if I go into this web term, I click on console, bring up, and I can get to this server, okay? This web server, this 192.168.0.1 is this web server right here, okay? I set up a static IP, I can go to configure, and if I hit edit the network configuration, you can see it's got 192.168.0.1. Okay, that might be very small, but I apologize for that. I did get a chance to play around with my PuTTY and get the PuTTY, I think, at a higher resolution, so you can see the writing a little bit better. But now it kind of, anyway, because the writing's bigger, it does more laugh over, but we'll live with that. All right. Anyway, so I just set up this router. It's doing DHCP out to these web terms, but the web server is static. And what we can do is we'll go in next class. I think that's how we'll start next class, and modify an access list on this router. Okay. So I'm going to open up the floor for questions, and then we'll pick up where we left off next virtual lecture. So any questions? All right. Oh, Sean, I see your mouth moving, but I don't hear you talking.
Oh, sorry, I forgot the space bar. It was an unrelated question to the lesson. It was just about the email with the due dates. I don't know if you want to wait.
Yeah, sorry. Yeah, Mo had that question too. There's the due dates are exactly the same. It's May 14th. When I said due dates, I was my due date. I'm setting a due date for midnight for me to get the stuff out. So, yeah, my fault. Didn't mean to panic.
No, it's cool. It's cool. You scared the crap out of a lot of people.
All right. Yeah, I'm sure everyone's on the team chat right, or team speak right now. Or I'm using an old term. I'm an old guy.
There we go.
First of all,
All
I
right,
did
we'll
have
keep.
Hopped on the AOL chat
is
room.
really
Yeah, the AOL chat room. Yeah, AOL. Yeah, on their bomb modems. All right, I'm going to stop the recording right now, and then we'll pick up, and then we can keep talking. But I'm going to stop the recording. All right, so we'll have there'll be a part 2 to this lecture. We'll pick up where we left off. We'll do an access list on that router, and then we'll finish up talking about privilege levels on iOS and a couple other access class and a couple other port security as well. So, all right, goodbye for now.